unfold. You know, for as long as we've been human, we've looked up at the night sky and asked, what is all this? Is any of it even real? It's one of the oldest questions we've ever asked. But what's so wild is that today, it's not just a philosophical thought experiment anymore. It's a serious scientific hypothesis that physicists are actually testing right now.
So let's just get right to it. Is our entire universe, everything you see, everything you are, is it all just an unbelievably advanced simulation? Kind of like a cosmic video game? I know, it sounds like it's pulled straight from the Matrix, right? But the clues suggesting it might actually be true? Well, they're hidden in the very laws of physics themselves.
In this idea that we're all just living in some kind of shadow reality, it's not actually new. We're talking thousands of years ago. Plato came up with his allegory of the cave, this idea of prisoners who only ever see shadows on a wall and mistake them for the real world. But here's what's changed. Scientists are now finding what look like, well, digital artifacts, baked into the fabric of the cosmos.
Okay, so this is where we basically become cosmic detectives. We're gonna look at the evidence, piece by piece, to see if the universe has those telltale signs of being a piece of software. You know, are there glitches in the matrix? So let's dive into the first clue. First up, resolution. In any digital world, if you zoom in far enough on an image, what do you see? You see the pixels. Well, believe it or not, scientists have found something uncannily similar in our universe. It's called the Planck length. It's the absolute smallest possible unit of space. This suggests that reality isn't smooth and continuous, but that it actually has a fundamental pixel size, which is a pretty clear limitation you'd expect to find in a simulation.
And what about speed? We all know the speed of light is the ultimate cosmic speed limit. Nothing can go faster. Now, in a purely physical universe, that's kind of weird, right? Why is there a limit? But in a computed universe, it makes perfect sense. Think of it as the universe's max processing speed, like the CPU clock speed of some giant cosmic computer that's limiting how fast information can travel across its own grid.
Okay, next, there's the really strange behavior of time. We know from Einstein's work that the faster you travel, the slower time actually passes for you. It's called time dilation. But if you look at it from a simulation perspective, this looks exactly like a computer processor starting to lag. When a task gets too demanding, like, say, calculating an object moving close to the system's maximum speed, the local clock slows down to avoid crashing the whole system. Sound familiar?
And what's really amazing is that it's not just one or two things. The parallels between physics and computer science are they're striking. The Planck length, that's your pixel size. The speed of light is the max processing speed. Even that quantum weirdness, entanglement, where two particles are mysteriously linked across vast distances, well, in a simulation, that could just be two particles pointing to the same address in the computer's memory. The patterns are they're everywhere you look.
This whole idea of saving resources connects directly to one of the biggest mysteries in quantum mechanics. You see, programmers use a clever technique called lazy evaluation. Basically, an engine only renders what the player is actively looking at to save power. Well, quantum physics seems to do the exact same thing. A particle exists in this weird, blurry wave of all possibilities until a conscious observer looks at it. That act of looking forces the universe to render a definite state. It's the ultimate resource-saving hack.
But maybe the most startling clue of all comes from the physicist S. James Gates, Jr. While he was working on some of the deepest equations of string theory, he found something that looked, for all the world, exactly like computer code. Specifically, the kind of error-correcting code that we use every day to stop data from getting corrupted in things like our web browsers. It was just there, seemingly embedded in the fundamental fabric of reality.
Okay, so the case seems pretty strong, doesn't it? We've got pixels, processing limits, lag. We've even got what looks like actual code. But just when you think this cosmic mystery is solved, a major piece of counter-evidence comes to light that just might change everything.
Yeah, it turns out that some really recent discoveries in both physics and mathematics pose a formidable, maybe even fatal challenge to this entire simulation hypothesis. The universe might have a core feature that makes it fundamentally impossible to simulate.
And this whole debate is moving incredibly fast. I mean, just look at this. In 2022, the Nobel Prize in Physics actually bolstered the theory. Then you have a proposed law suggesting the universe compresses data like a computer. But then, a landmark study from physicists at UBCO dropped an absolute bombshell.
So these researchers argued that our universe contains truths that are non-algorithmic. What does that even mean, right? Well, it means there are aspects of reality, like the way space-time itself seems to be continuously generating, that simply cannot be solved by any step-by-step computer program. And if reality contains things that are literally uncomputable, then by definition, it can't be a computer simulation.
And there's another massive problem, the energy budget. Think of it as a power supply issue. A recent study actually calculated the energy needed to run a high-fidelity simulation of our universe. The result? It would require more energy than exists in our entire universe. The computer running our reality would have to be exponentially larger and more energy-rich than the reality it's creating.
So the physics of it is this incredible battlefield of competing ideas. But let's set all that aside for a second and ask the question that really truly matters. If we are in a simulation, what does that mean for us? Who, or maybe what, are we?
This is the moment where the abstract science becomes deeply personal. Are we the players, the ones with our hands on the controls, or are we just part of the program itself? I mean, this question cuts right to the core of what it means to be conscious, to have free will.
Well, the philosopher Nick Bostrom laid out this powerful and kind of terrifying statistical argument. He said one of these three statements has to be true. Now, if civilizations don't all go extinct or just lose interest in technology, they will inevitably create countless ancestor simulations. Think about it. That means the number of simulated minds would vastly outnumber real biological ones. And the statistical takeaway is staggering. If you think that's likely, then it's almost a mathematical certainty that we are in one of those simulations right now.
And that leads to a really, well, an unsettling idea, the NPC problem. If this is all a simulation, are you a player, a conscious being with real free will? Or are some people just non-player characters, philosophical zombies, just running a simple script with no one really home inside? The system might only bother to render full, rich consciousness for a few key players, just to save on resources.
Now, we have to be really clear here. This is a dangerous path to go down. Believing that other people aren't real can justify a profound lack of empathy. It's a way of thinking that could completely erode our entire moral framework. And that's why most philosophers treat this as a cautionary tale, not as a serious possibility to entertain.
So after all of this, all these clues, all these counter-arguments, what should we take away from it? I mean, if we really are living inside a computer, does that make our lives, our loves, our struggles, does that make it all meaningless?
Well, the philosopher David Chalmers offers a really powerful answer. Absolutely not. He calls it virtual realism. A simulated world isn't a fake world, it's just a world built on a different foundation. Your experiences are real, your relationships are real. The chair you're sitting on right now is still a chair, it just might be made of pure information instead of matter, which, hey, according to a lot of modern physics, might be the same thing anyway.
And that's really the crucial point, isn't it? This whole investigation into a computational cosmos, it forces us to confront the biggest mystery of all, ourselves. The real puzzle we're trying to solve here is the tension between the code of the universe and the nature of our own consciousness.
And so that leaves us with the ultimate question. Which one is more fundamental? The information that builds the world around us or the consciousness that experiences it? Is our universe a perfectly executed program, or is that spark of awareness that's inside of you something that can never, ever be simulated?